So let's start. So the talk that I will give today is about EKS blueprints, Jenkins and Scale. Okay, so a little bit about me. So I work for CloudBees now 9 years, so that means that I am happy working there. I started working as a support engineer, and then I moved to service kind of role. Before this, I started in the environmental science sector, I told you. So I started working with a geographic information system, and then I started to be more implicated with data, and automation. And that brings me to take IT studies, and I started as a software developer engineer. And that's it, a little bit about my background. Since I work in service, I am maintaining this project that is the CloudBees CI and CD Terraform EKS add-on. And why I use this project for my engagement. All of us, we know that the documentation gets out of date very soon, And when you work with a company and they have a huge base of documentation, it's difficult to get lost. So what I'm trying to do with this EKS blueprint is having patterns where you can see different implementation of features that we can find in our documentation, but you can interact with them, you can experiment with them. So that's the idea behind this project. So apart from my work at CloudBees, I work as part-time, not paid. So I am a community organizer in the Cloud Native Seville group. So also you are invited to give a talk there if you want. So we can go for tapas in Seville. I will be your guy. So you are most invited. You can reach me through Fabio or anyone of here, can pass my contacts. So the agenda will be 3 blocks. First, we are going to talk about AWS. Second, we are going to talk about running Jenkins in Kubernetes. And lately, we are mixing those concepts, and we are see how we can use the AWS EKS blueprint, with Jenkins to create the CloudBees EKS add-on. Finally, we go through takeaways and Q&A. I have calculated my time, and I think it's fit perfectly in those 30 minutes. So let's start with the AWS part. What are the Terraform EKS blueprint? So we have AWS cloud service. So we want to configure it using Terraform files as well as declarative help configuration of releases of different cloud native service or service in general. And supporting in best practice. That's what EKS blueprints are about. So as you can see it on the right-hand side, you see examples of different implementation of EKS blueprints that you can find in that project, Terraform AWS EKS blueprint, that it helps you to experiment with different implementation implementation or configuration, things like Campenter, GitOps, anything that you can imagine. So our opinionated pattern that they are maintaining by AWS solution architect. So it's a community effort. It's not supported officially by AWS. The main pillars are 2. One is the AWS EKS blueprint add-on, and then the AWS EKS cluster. Both of them are Terraform module. How do they look like? So in here, we see that on the top we have the blueprints add-on, and then on the bottom, the AWS EKS cluster. So for the EKS cluster, most of you if you work with Terraform, you might be familiarized with it. So then we have 2 types of add-on. We have the EKS add-on and the blueprints add-on. And what is the difference? We are going to explain in the next slide. So the EKS add-ons and add-ons that they are native and they are supported by AWS. Some of them are from AWS and others are for third-party vendors. And they can be installed in different ways, using AWS Console, AWS CLI, infrastructure as code, using Terraform or CloudFormation. So they are, some of them, they are many basic, well, they are very basic, and they are mandatory. For example, CoreDNX or Kubeproxy are things that you need to install it by default, okay? But there are others that you can install, like pod identity to interact with different AWS services, OpenTelemetry, as well as third-party vendors. So now we have the other type of blueprints. So these are the EKS Blueprints add-ons, okay? So those are community-driven. And the only way to implement those are using Terraform code. So in there you have a huge variety of different add-ons that it will be just by enabling switching a flag from true to false to having ready in your cluster. So so the power of this is that you don't need to reinvent the wheel, okay? Because when you start in the company, what I try to implement in my team is that I saw that many people were basically doing what the AWS consultant were doing for you. Okay, so what's the point to maintain your own modules when you can actually pull what AWS engineers do? And also, the important thing is that you can contribute back to that community. If those blueprints add-on were not enough, you can extend, okay, to install more releases using the additional application using the Helm releases component. Okay, so here, as you can see in this example, they are adding other applications to the stack. And then finally, apart from the EKS Blueprints add-on that they are managed by the AWS consultant, also the partners at CloudBees at CloudBees it's one of the partners of AWS. We also have our own add-on. Okay, so as you can see at the bottom of the list, okay, that is the CloudBees and this the aim of the context of this talk. So this is about EKS Blueprint. Second part of the talk, running Jenkins in Kubernetes. Okay, Jenkins has more than 20 years today. Okay, it started in 2004 as a Hudson that it was created by Kosuke. And in 2011, it was forked into Jenkins. Why? Because the company that Kosuke was working on at that time was Sun, and then was acquired by Oracle. They wanted to not making open source, but doing fully enterprise. So that's why he decided to leave the company at that time and fork it in what is today Jenkins. So the important part about the dates is that the origin of Jenkins 2004, okay, was even before that the birth of the cloud computing service, okay, because the first release of EC2 and S3, EC2 and S3 is 2006. Jenkins, as you know, is an open source automation server that is using to orchestrate CI and CD pipelines in your software development lifecycle. So what are a pipeline? A pipeline is a consecutive, a series of concatenated stages, and within every stage that classically in CIR checkout, test and build, okay? Then you are orchestrating a series of steps. And CD, it's also a pipeline about a step, but there are where you move your active app into your environment. When Jenkins was created as a general purpose tool for the good and for the bad. That means that it has embraced different architectures and extensibility mechanism. Okay, today Jenkins has more than 1,800 plugins. Okay, it's too much. Many of them, okay, they are not they are not, or they are donated, or the contribution efforts has decreased. So that's why it was released the health score feature. Okay, the health score feature, what it tells you is it's about the credibility of that plugin, and it's measuring about the dependencies, the security mechanism, if the documentation is completed, the adoption. So when you install a Jenkins plugin in production in your Jenkins system, please look at the health score before installing. About the architecture, Jenkins is a distributed architecture node. Okay, so we have a controller. Okay, and that controller is connected to different slaves. Okay, or agents, and they are connected via TCP or WebSocket. So what the controller does, that are the brands, they are delegating the responsibility of running those pipelines. Okay, important. Anything that is not running within an SH or BAT state or BAT step, okay, it will be running on Jenkins, because a classic problem for customers that I work with is that they have a huge library of Grubby, okay, of poor Grubby, that they are not running with any SH or BAT step, and all that Grubby is running on the controller, and they can cause overhead. Okay, so a well-designed pipeline. It will have using Groovy as a glue, okay? And then once you allocate a node, it's important to make a call to a SH step for Linux or BAT step for Windows, okay? To delegate the execution of that pipeline into an agent. Is still Jenkins relevant? Is still Jenkins relevant, and it's not something that I am telling you. I am supporting that statement based on data. Okay, so if you have a look on the Jenkins stat, you will see that today there are more than 3,000 Jenkins controllers, more than 1.2 million of nodes between controllers and agent, and 80 million of jobs. But not all the information for Jenkins instances are sent to that stats, because we have to think on air-gapped environment, for example, for banks and people that just disable the stat features. Okay, CloudBees is the company that I'm working for. Is the first sponsor of Jenkins, but it's not the unique. Okay, as you can see here, there are other sponsors that they give money or infrastructure or a bit of both. So we have OSL, we have the CD Foundation, AWS, GitHub, and JFrog are supporting the project. So how everything works? I said that Jenkins started in 2004. Okay, so there was a moment that, hey, let's move to the cloud. So thanks to the way that Jenkins was designed, it was designed as a cloud agnostic tool. And the power of Jenkins in comparison with other CI/CD tools is that it's agnostic almost for everything. You can plug any source code management system. You can deploy it on any environment that you can think of. So that's one of the advantages of this tool. So there were two movements, okay, before 2018 and after 2018. So before 2018, what happened at that time, okay? So Jenkins was able to deploy it, to deploy these VMs, okay? Also was able to spin up ephemeral controllers using the EC2 Cloud plugin, the EC2 Cloud plugin. Also, it was able to save artifacts in AWS. And also using integration with PaaS. But in 2018, what happened is that the creator of Jenkins, again Kosuke, he wrote a blog post about 16 years moving toward Cloud Native Jenkins. So if you look at that blog post, you will see a series of initiatives that was taken to make Jenkins Cloud Native. Is Jenkins Cloud Native today? The answer is no. Jenkins is not Cloud Native. Jenkins is cloud friendly. And from those projects that you will find there, the ones that I would like to highlight will be the Helm installer for Kubernetes, configuration as code, and pluggable storage. Okay, Let's start with configuration as code. So configuration as code, what is that? Is the principle of, hey ma'am, I am deploying Jenkins without my hands, okay? So it's trying to avoid the ClipOps approach to a GitOps upload. And what are the advantage of those? That all the configuration go to a source code management system. So then you have capabilities of auditing, you have capabilities of branchings, and also because everything is stored as code, then you can do replicas of that deployment from one environment to another easily. So in case of a disaster recovery, in case of something goes wrong, you can recreate your environment. That configuration as code is integrating with help chart. What does it mean? That at the same time that you are installing the application, you are also configuring it. Then let's move to pluggable store. The main problem that make Jenkins cloud-friendly and not cloud-native is the dependency of the file stored, okay? So Jenkins depends a lot on a file system, okay? And a general on a file system to store different type of information because it started as a general tool, kind of monolithic approach. So today, in the distributed cloud-native application, so we see that there are different applications that they are doing one thing, but they are doing that thing very correctly, very right. And what happened with Jenkins? That Jenkins started doing everything. So it was a place to store credentials. It was a place to store artifacts. It was a place to do your authentication. So that's one of the problems that we are trying to solve the community and CloudBees, okay, to try to decoupling all that configuration. So what is the status of this project? So the green color represents all the areas that has been completed. So we have artifacts, we have credentials, we have system log, and we have test result. Then we have partials, partial areas completed, like build logs, configuration, and fingerprints, and areas that has not been started, build, tax load, code coverage. So you want to see some of the features that I have been talking today in action. You can do it easily. You get inside that project and it's Jenkins on Jenkins. What is Jenkins on Jenkins? It's the dog food instance where we run all the CI process for the Jenkins core in the different distribution, but not only that, also for all the plugins that are developed for the community. So this is the second time that I did this talk. Okay, the first one was in Madrid. This one in my language. This one is in English. It's been a bit. I have less flow, less to say. So at that time, I contact with the infra team. I say, hey, I open that ticket that you see there, and I say, hey, can you give me some examples of interaction of Jenkins with the cloud? So in that ticket, if you access, you can see several examples of interaction of Jenkins with the cloud, like ephemeral agents running in Kubernetes, ephemeral agents running on Azure VMs, okay, as well as Docker-based. This platform, okay, it's running, the controllers is running on EKS, okay, but also have agents running on EKS. Also open source lab, among other controllers. So what is the Jenkins pain? Okay, so the Jenkins pain is that when many of you asked me when we started at university, yeah, it's a long time ago, when we started with Jenkins, hey, I love Jenkins because it's so quick to start, okay? So I can start with my with my project so quickly. So what happened that after several years, when you are not working in your lab, when you are working in a production environment, and you instead of having the care of separating different controllers for different teams, you have onboarded all the teams, all the developers into the same controller. That Jenkins turned in what we call Franken Jenkins. Is what you can see there. It's a massive Jenkins with a hard consumption of CPU, memory, storage. And the problem is not that. The problem is that if that controller for any reason fail, it's a single point of failure. Okay, so that's the problem. That's one of the the most important problem. So that's CloudBees was aware of the problems, and then it provides a series of features to make Jenkins even more cloud-friendly. What are those features? Okay, let's start with the operation center. That is the element that we see in the architecture on our left. So operation center, what it does, it's a shared context that it will connect those isolated Jenkins instances that you might have if you have separated Jenkins instances per team, okay, and they connected together. Why do you want to having them connected together? For things like SSO, for things like having a Kubernetes template library for deploying your agents, for things like credentials. Then we have the HA, the high availability and horizontal scaling features. Okay, so today you can have more than one replica of a controller running. Okay, so this will eliminate the bottleneck of the single point of failure. Okay, so if for some reason one replica goes down, there will be another replica that it will take over all the orchestration of those jobs. Okay, so we can have from 1 to n replicas, but also we can have 0 replicas on those controllers that they are not doing any job. Okay, so then we will save cost. That's what is the hibernation feature about. And finally, we can do multi-cloud deployments. Okay, so you can have maybe your operation center running on one provider and one of the controllers running on your private data center is OpenShift, and then you have another controller running on Azure. That is possible. I'm going to drink a little bit of water, if you don't mind. Thank you. So let's go to the final part. Okay. So the final part is about the EKS Blueprints Jenkins at scale. So we have covered Jenkins running Jenkins Kubernetes, and what we do, we put on the top of a blueprint, and that's why we create the EKS Blueprint. So what are the Jenkins at scale blueprints? So it's the replacement of the CloudBees CA AWS Quick Start. I don't know if you are aware of the AWS Quick Start. So that was a previous project where AWS offers to their partners to experiment with the services. So it was more like a black box that it was hosted in the repository of AWS and was very difficult to maintain. So to all AWS partners, we have been advised to move to this approach, to using what it's called the AWS Partner Add-on. So the Jenkins at scale blueprint is one of the blueprints that is testing the AWS Partner Add-on. And what is trying to demonstrate? It's trying to demonstrate a scale and resilient architecture. Is showing enterprise features that are related to CloudBees in the previous slide I showed you before, as well as integration with AWS service. So this is the official page of the AWS Partner Add-on. CloudBees CI is one of them. And at the end, what it is a Terraform module, as it could be EFS or S3 that you can incorporate in your Terraform workflow. The structure, so this structure that it has followed the project is the same that all the partners add-on. So you have at root level, you have the configuration of the Helm release for the project and application. Not only the Helm release, there will be another Kubernetes resources that it can be added. In this case, it can be added Kubernetes secret or service monitoring for Prometheus. There are series of features that we incorporate to the Helm release. And also, it has files related to the CI process of that blueprint. Some of the CI process is hosted in the CloudBees platform. Okay, that is our platform was released like 2 years ago, and other part it's being hosted in GitHub. Okay, other part, like the rest of the atom. And then inside the blueprints folder, if you open them, you will see a series of blueprints. We have one for getting started, that is the minimum configuration to get CloudBees CI up and running. We have this one about Jenkins at scale, and we have another about Carpenter. And then on the right side, we see the structure of the CloudBees CI module. So we have the CI folder that what it contains is all the configuration as code that I explained before for configuring the project, and also shared libraries. And then we have help values for other applications that you integrate with. And then you have the root module. And then in the root module, what is using is the top definition of the atom plus other supported resources, EKS, EFS, or anything that you want to use. About architecture, so this blueprint specifically is using cluster auto-scaling as a scaling mechanism. Okay, as you can see, it has divided 4 different EKS managed work groups. The two at the top, they use on-demand instances because they are services, they are running constantly, okay? And the two at the bottom, they are using spot instances. Why? Because they are doing ephemeral jobs, okay? Then they are doing all the build, and thanks of using a spot, we will making savings in our cloud billing, okay? There is a feature in CloudBees CI, well, in Jenkins, that is the retry option. So the retry option, when you incorporate in your pipeline, if for some reason a spot instance get decommissionated, okay, the controller will take care to search for another spot instance and continue the job, okay? Then about the architecture of the node, what we use is Graviton. Graviton is the best option for performance and also for the cost. And then about the operation system, we use BottleRocket. Why BottleRocket? Because BottleRocket saves you time. Well, it's an operation system that is designed specifically for containers, and it saves you time in terms of maintenance for security patches, for example. Then, looking at the CloudBees CI managed node group, okay, we have 2 types of storage. We can do it using EBS, and we can do it using EFS. With EBS, it's for those controllers that specifically require lower latency, okay? But the contraside is that the scope of the EBS is the availability zone. Okay, so you need to make sure that in your storage class definition, they are tied to that availability zone. Why? Because in case one controller gets restarted, it's required to get restarted in the same availability zone that was initially created. Otherwise, you have a volume conflict. On the other side, we have the EFS. EFS is a service that is more expensive than EBS, but it provides you with high availability. Why? Because it prevents you for zonal outage. EFS is a requirement of controllers running on HA and HA. HA and HS is optional for non-HA controllers. Okay. About the backup system, for EBS we use Velero for backing up, and for EFS we use AWS backup. Then finally, this is one of the last slides. So this is how it looks, the workloads. Okay. So on we start with the minimal requirements that are those ones that are used in the getting started blueprints. That are the ALB controller, external DNS, EBS or EFS CS driver. Okay, and then we are going to put the focus on the CloudBees area. That is that one that is dotted in black. That all that configuration comes from the EKS add-on. So we see 2 namespaces for different separation of consent. and they are using pod identity. We see one on the left side, on the left hand side for interacting with S3, and another in the right side that is for the agent for for interacting with ECR. More things than we see in the CVCI space. We see the hibernation monitor that it will be watching all the build queue in case any of the controllers moved or transitioned to hibernation state to wake them up. And then also we see a Kubernetes secret. Why? Because we store all the configuration in a source code management system, but we don't want to store sensitive information, okay? So that's why we have a secret to connect with the configuration as code that it will be matching via environmental variables. Then then we have the structure of the CloudBees platform. We see in the middle, in the central part, the operation center, and then it's connecting with 3 controllers. One running on HA mode, okay? Another 2 that they are not using HA mode. Also, one of the controllers, they are not using configuration as code. And this is to see the differences, okay? Because the controller that is not using configuration as code, when you access to that controller, you will see that you need to ask for, it will be using the license, it will be asking the license for other things that they will be configured directly using configuration as code. Then agents, for the agents, we have templates for Windows, and we have templates for Linux, and we have Canico to perform all the Docker, well, not the Docker, all the build and push of the images. Okay, so Canico is what we use for building images. You can build them in ECR, okay, thanks to the identity pod, then it will be providing the ECR credential, or that secret that it will be mounted in the template for deploying in Docker Hub, okay. Other services that we see, it's Vault for credential, OpenLDAP for authentication, the BottleRocket operator, then it will be taking care of updating all the BottleRocket MEIs, well, no MEIs, sorry, operation system, to make sure that they are up to date. The good thing about the BottleRocket operator is that you can specify a Windows when you go to perform the maintenance, where normally you perform the maintenance. Normally it's at weekends. Cert Manager is a dependency of the BottleRocket. We use SEM, so we don't need that for the certificate. And then we see also all the observability stack. So for the observability stack, we have 2 routers. One is FluentB, and the other one is the OpenTelemetry collector. Okay, so those routers, the OpenTelemetry collector, will be sending metrics to Prometheus, tracing to Tempo. Well, logs is disabled in this case. If FluentB will be the responsible to sending logs to Loki. Okay, Grafana, it will be the component that it will be connected to all those data sources, and you can explore that data. But alternative data is also sent to CloudWatch. Takeaways. So being cloud friendly is a must. And being cloud native, in some cases, can be optional. Infrastructure and configuration as code is a universal language for DevOps professionals. At the time that you want to enable other people to contact with enterprise features or for driving adoption, because it's like the documentation. And finally, building demos on the top of community frameworks like the EKS Blueprint increase the reliability and development speed. So that's all. So now you have QA questions. Thanks for bearing the talk.
Do we have any questions in the room? No. Any questions in the room? Please.
Yeah, you have a mic there. Just
Thank you so much for the talk and for presenting the work that you are doing with Jenkins into Kubernetes. I would like to ask, what is the experience of building an EKS add-on, and what are the difficulties on creating new add-ons to EKS?
It was not difficult at all because, as I presented in one of the slides, you can take as an example one of the other companies add-on as a reference, and then you start building from them. Okay, so you have a model that you can use as a reference, as a template. So it was not difficult to do. And also today, thanks to tools like Amazon Q or Jihad Copilot, it has increased your development speed so quickly.
No one has a question, I do have a question. So when you were planning this kind of architecture, you had multiple clouds for you to pick. Why did you pick AWS?
Because this project, well, to be honest with you, most of our customers, the biggest percentage, I don't know if it's a 52, they are in AWS. I think many people today is the most used cloud, okay? And also, we pick up AWS to take advantage of the EKS Blueprint. Okay, so it's a project that ran for the community. So now, joining to that community effort is like we are part of that project. So meaning that we have more people working for services that they work for EKS Blueprint, and we try and the way that we work has changed, because in the past it was us creating our own modules for EFS, for things that today, well, EFS, not for EFS specifically, but for example, for Verero, for Prometheus Stat. But now, what we are doing is reusing the work that AWS consultants are doing. And if we find anything that can be improved, what we do is contribute it to the community.
Thank you. So we do have a question for that.
Okay. So we see a lot of companies trying to move away from Jenkins to go to more cloud-native solutions, but you saw that you are trying to decouple now the storage from Jenkins. Do you see Jenkins becoming another cloud-native solution in a couple of years?
Well, there is a lot of technical debt that need to be solved. I don't have an answer to that now. Okay, I mean there are efforts driving toward that. Okay, but I don't know. I don't have I wish it will be like that, but I don't have an answer now. Thank you for the question. Thank you.